Okay, what's going on, guys? It's your boy, Master John here, with a Wednesday edition of calculus class. We're all so ready for it, aren't we? So what we're going to be talking about here today will be the solutions to the last AP questions in the next set, but kind of a little note I want up here is that we are officially in the fourth marking period. For class participation grades, just comment below on the video anything that you want. I don't really care what it is. I just need to see that you're seeing these and can acknowledge that it is you. That's all I really need. If we're not back to school by May, I'm going to need you to start sending me pictures of the work that you have done. We'll probably start that post-AP test, which is May 12th. Okay, email there, so please just respond to these videos, and we're going to have to talk about tests in the future, but I'm going to wait until after the AP till we start talking about what we need to do for SUPA testing. I know, a word we're all cringing at right now. Okay, on with the questions that I had assigned before. So 2013, question 3. Whenever you see questions kind of open up with a grid like this, this is typically going to correspond with Riemann Sum types of questions, and they're going to give you some BS story. So here it's hot water dripping through a coffee maker, and it gives you the amount of coffee in the cup at some time between 0 and 6. Specifically, they give you the amount at all the integer values from 0 to 6. The first thing it's asking us for in part A is to approximate the derivative at 3.5. And you may be thinking, well, we don't have 3.5 here. However, we do have the numbers between 3 and 4. And if you want 3.5, we would average that. And remember, derivative means slope. So we can find the slope here between 3 and 4. So what we're going to be looking for here is kind of our slope equation. C of 4 minus C of 3 over 4 minus 3. So the denominator I got, that's 1. Oh, great. Now we got to do 12.8 minus 11.2. And that gets us a 1.6. Great. And you may think that you're all done here. However, it also says to indicate units of measure. So notice C of t was in the top. That's kind of like our y values anyway. So that's ounces per minutes. So at that moment, we would approximate that there's 1.6 ounces per minute getting put into the cup here. And if you're looking for a point breakdown, it is 1 for the number, 1.6, and 1 for the unit. So don't forget those units if they ask for them. Okay, is there a time between 2 and 4 at which the rate is 2? So kind of the slope is 2 there. So whenever they're asking us for these intervals, don't think, oh, do we have to do 2 to 3? Do we have to test 3 to 4? 2 to 4? If they give you intervals, they're not trying to trick you here. Use 4 and use 2 and see if that works out. So I would be saying C of 4 minus C of 2 over 4 minus 2. C of 4, 12.8 minus 8.8. That's a nice one. All over 4 minus 2. So we have 4 over 2, which is 2. And that's exactly what we wanted. Ding, ding, ding. That's a good one. However, that is not enough. We need to say why this works. Why can we do this? And that may involve a little bit more of this justification here, right? If this is justify your answer, we need a little bit more. The key word in this whole kind of opening phrase here they give us is differentiable. If something is differentiable, that means we can take the derivative, but it also implies that it's something else. Continuous. So since it's continuous, that means we can actually apply the mean value theorem, MVT, mean value theorem. And so since we have that the endpoints have a slope of 2, that means there must be some point in between that has a slope of 2. So mean value theorem says that yes, this is going to be true. There exists at least some t in this interval 2 to 4, such that the derivative there is 2. Don't worry about all that notation. You can write that out and just say what I kind of verbally said. Okay, on to use midpoint sum with 3 subintervals of equal length indicated in the data in the table to approximate this value of 1/6. It says that. I'm going to do that. I'm not even going to see what the next bit says. So 3 subintervals of the same length. Since we're going from 0 to 6, these are going to be our subintervals. 0 to 2, 2 to 4, 4 to 6 that I've marked up here in the blue. But it says midpoint. So really the numbers we want to look at are 1, 3, and 5. Those are our big important ones. And this is really all indicating to us that we're going to use some Riemann sums. So if you wanted a nice visual of what's going on here, so 1 goes up to 5.3. So let's say this is 5.3. So that's our first rectangle. 3 is going up to, what does it say, 11.2. That would be our next one, and then the last one, 13.8. And notice these numbers are in the middle. And since we're doing these Riemann sums, we want to actually find out what the area of each one of these is and add them up. So we want 1/6 times this integral. That's going to be 1/6 times, well, the area here, the base has a length of 2. The height is whatever c of 1 is. This next one, we're adding to it, also has a base length of 2, right? Because we're going from 2 to 4. C of 3 plus 2 times C of 5. Let's plug these in and see what we're getting. 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8. And I'm not really looking through to multiplying all those by 2. I can factor that 2 out front, make this a 1/3, which means I just have to add these decimals in here because who wants to multiply times 2. Okay, adding these together because I like that 8 and the 2. That gets us 25 here, plus 5.3, 30.3. We want 1/3 of that. Oh, that actually divides out really nice. 10.1. Okay, so now we're here. And the next part, it says using correct units, explain the meaning. So that's 10.1 ounces is what we're looking for, because that's all the numbers we're adding up here come from this point. And that would be, since we're dividing by that whole sum, that's the average amount of coffee in the cup over that time interval. So that's the average amount of coffee in the cup from 0 to 6 minutes. So hopefully that average part makes sense because we're doing the 1/6. And I forgot to do the point breakdown of the last one as well. So point breakdown, you got 1 point for showing it was 2 and 1 point for mean value theorem. On this one here, point breakdown is you get 1 point for setting this up correctly, showing what you're multiplying, 1 point for the correct number answer, and 1 point for the correct meaning. Remember, these are out of 9, and we have 3, 4, 5, 6, 7. So only 2 points on this last one. Okay. The amount of coffee in the cup in ounces is modeled by this equation we have here. 16 minus 16e to the negative 0.4t. Use this model to find the rate at which the amount of coffee in the cup is changing when time is 5. Rate, that should be a keyword telling us that's changing something. That means if we have this initial formula and we want the rate of it at some point, we need to do the calculus thing, take a derivative. So that's a -16 derivative with this e. We're multiplying by -0.4, e to the -0.4t. Multiplying those, that's -6.4, e to the -0.4t. That's the general equation, but they wanted it at 5, so we have to put 5 in there. -0.4 times 5, that's really the same thing as e to the -2. And I'm fine with that answer, and we need to do units here or no? No, units don't even matter here because they don't say indicate in units. So you get 1 point here actually for the correct derivative and 1 point for just plugging in 5 and rewriting it. That's actually pretty nice. I don't think I've said this before, but notice for a lot of these, there are usually 3 or 4 parts. You can get points on different parts even without knowing how to do the other ones. You could have done part D even if you had no idea how to do these ones up here. Just notice the word rate, take a derivative, go, and you get your nice 2 points here. Okay, about 10 minutes to do that one. Let's look at this next one. This is one where I'm instantly identifying they have a derivative graph. That's like the question we did on the last AP we went over. So this is a very common question where they give you a graph of a derivative of a function, and then they're asking you things about the function from there. All of this stuff in here is pretty much just identifying what you would assume. Horizontal tangent lines, so we can see like here, here. It's the ones that you think they would be. They cross all at the nice values. And the only other important piece of information here is right there, that the value of f of 8 is just 4. Okay. It's now asking us to find all values between 0 and 8, which it has a local minimum. So remember, to obtain a local minimum, that means we're going from decreasing to increasing for our function. Well, if we're going from decreasing to increasing, that means the derivative goes from negative to the derivative is now positive. So look on this graph. Positive derivatives are above the x-axis, negative are below. So where do we go from negative to positive? There's really only 1 point here where that's going to happen at. Right here, we're going from negative to positive. So our local minimum is at x equals, what is that, 6? Since f prime goes from negative to positive. And that's all we need here. That's 1 point though. I wish it was 2. But we'll take the 1 point there. Not too bad. Determine the absolute minimum value of f on the closed interval from 0 to 8. So you may be thinking, well, we just got to find this value. We just found the local minimum. But remember here, in going through these, the possible minimums can be the local mins in between as well as the endpoints. So what I'm thinking right away is we need to check endpoints. And f of 6. Those are all the things we're going to need to look at here. Okay, let's try to squeeze that down here. So our endpoints, we need f of 8. Luckily, we know that one's 4, since they told us that right away. Now we're going to need f of 6 to be our next one we're looking at. Well, this may be puzzling on how we can find that, but we know a piece of information we can use here. So what I'm thinking is the integral of this function from 6 to 8 is going to be f of 8 minus f of 6. You may be like, well, how's that help me? Well, from 6 to 8, how much area is there? It tells us nice and neatly that there's 7 area. We know f of 8 is 4. So f of 6 now is going to become, what's that we subtract? F of 6 is -3 here. All right, so I'm just putting that up here. Okay, we now also need to check 0. So we can think, right, because I want to check f of 0. And this is going to be f of 8 minus f of 0. And we know f of 8 is 4. But now, knowing that big interval here, that may be a little bit more challenging. So we have to think, well, what are the areas we have here? We have 2, 6, 3, 7. So we can just add all those up, right? Not quite. 2 plus 6 minus 3, since it's underneath the curve, plus 7 equals 4 minus whatever f of 0 is. So adding these up here, we have 8 plus 7 is 15 minus 3. So we have f of 0 equals, what, -8 here? So they want what is the absolute minimum, so which one of these is the smallest, and it is, in fact, this value here is the smallest. So 0 is where our absolute minimum is going to occur at. And let's see what the points are. We need to consider 0 and 6